Let's get going with this practice quiz for Unit 1, solving equations and algebraic justification as we go through and do these. You'll notice that the first part, all we have to do is just solve the equation. Remember, we always want to make sure we're showing our work and our thinking as we go through so everybody knows we know what we're doing. We want to write our answers in the correct form, circle our answers so everybody's clear on what we think the answer is. And then remember, if we've got a decimal answer, we want to round to the nearest hundred if that's appropriate. So let's take a look at number 1. First thing we want to do is we want to get that a term by itself, that variable term by itself. So we're going to subtract 9 from both sides. So we end up with, because those cancel each other out, to be 0. So we end up with negative a equals, this is an 8 on this side. And then we're going to divide both sides by negative 1. Or you can just think I need the opposite of a, so I need positive a, so I need the opposite of 8, so I need negative 8. So we've got negative 8 equals a. Go ahead and circle that. That's the answer. Again, no problem if you wanted to take this and flip this around and write a equals negative 8. Either way would be fine. Number 2, we're going to do some distribution. So we're going to distribute through here. So this is going to be negative 8 equals negative 2z minus 14. I'm going to go ahead and increase the size here so we've got plenty of room. Let's see. Let's isolate that variable term. Let's move that 14 over to the other side. Let's do that by adding 14. Again, these are additive inverses, so they're going to cancel each other off. We've got a negative 2z here, and then we've got a 6 on this side. And we're going to divide both sides by negative 2. So we end up with z equals negative 3. We'll go ahead and circle that. Now notice that if I did put z on this side and negative 3 over there, there's no problem there, but we'll go ahead and leave it that way. Take a look at number 4, pardon me, number 3. Both sides are simplified. We've got a variable on each side. We usually want to move the smallest one, so that's going to mean moving this one right here. So we're going to move 2n to this side by adding 2n. Those are going to cancel out. They're additive inverses, so we're going to get a 0 out of those. If we're going to get the variable over on this side, we might as well at the same time move the 20 over to the other side. So I'm going to go ahead and subtract 20, and those are going to cancel each other out. So here's what we get. We get 6n on this side, and then we get 53 minus 20. So that's going to be 33. And then we'll go through and divide, of course, so we end up with n is equal to, now 6 doesn't go into 33 evenly, so we stop thinking of this as a division problem, we start thinking of it as a fraction. So these are both multiples of 3. 3 goes in here 11 times, and 3 goes in here twice, so the answer on this one is 11 halves. All right, next one, again, some simplification to do, so we'll go ahead and distribute. So we've got 6y minus 5 on this side, negative 6y minus 3 over here. I'm going to go ahead and move that 6y to this side, so we're going to add 6y to both sides. Again, those will cancel off. If I'm getting the y's on this side, we might as well move the 5 to the other side at the same time, so let's go ahead and get rid of that. We'll add 5 on each side. So we end up with, we've got here a 12y, and then over on this side we've got a 2. Divide by 12. We run into the same thing as we did on this last one. We've got 12 doesn't go into 2 evenly, so we just reduce that. 2 goes in here once, 2 goes in there 6 times, so the answer on this one is 1/6. All right, again on number 5, some distributing. So this is a 30, this is minus 20v. We've got a v plus a 21 over here. I'm going to move the 20v on this side, and I'm going to move the 21 over here, so we're going to subtract 21. Let's see, so we get 21v, and over here we have a 9. We're going to divide both sides by 21. Same problem we ran into before, but we can reduce this. 3 goes in here 3 times, 3 goes in there 7 times, so the answer on this one is 3/7. All right, no simplifying to do here, but we do have some like terms to combine here, so let's put 4v. And then this is going to be plus 14 equals 34. We're going to move the 14 to the other side by subtracting 14. 4v equals 34 minus 14 is 20. We're going to divide both sides by 4, so we get v equals 5. Circle that, and we're all set to go. Slide down here and take a look at a couple of these other equations, and we'll be done with this first page in just a second. We do have a decimal on this problem, so we may end up working with decimals, but let's go ahead and distribute and see where we end up. So this is going to be 4k plus 12 plus 2, and then on this side 4.5k plus 4.5. Let's see, let's move the 4, well, let's finish simplifying here. Put those together, we get a 14. So this is 4k plus 14 equals 4.5k plus 4.5. And we're going to move the 4k to the other side. We're going to subtract 4k. We're also going to move this 4.5 over there. So we've got the variables on this side and then the constants on this side. So double check me here. I've got 4.5k minus 4k, so that's going to be 0.5k. And then on the other side, we have 14 minus 4.5. That's going to be 9.5. So we'll have 9.5 here. And then we'll go ahead and we'll divide by 0.5 and cancel those off. So we get a k on this side. Go ahead and grab your calculator if you need to. I'm going to make sure that I get this right. So we're going to do 9.5 divided by 0.5. I think this is going to work out pretty well. So let's see, I'll clear this off. 9.5 divided by 0.5. We end up with 19. So lo and behold, on a problem that had decimals in it, the answer does not have a decimal. Okay. Now on this problem right here on number 8, if you want to work with the fractions, that would be totally okay. We could isolate the variable term by moving the 1/9 to the other side. If you want to do that, that's totally fine. I'm going to take this one and I'm going to clear the fractions here. We want to multiply by something that will get rid of a 9, a 3, and an 18. We want to multiply by the least common multiple here. So the smallest thing we could multiply everything by that would cancel off the denominator would be 18. So when we multiply the term 1/9 by 18, we get a 2. Because the 9 and the 18 cancel, the 18 cancels to be a 2. The 3 will cancel with the 18 to be a 6, so this is going to be 6 times 2, so that's going to be negative 12b. And then over on the other side, we have 18 times 1/18, that's going to be a 1. Of course, we're going to move this and solve this just like we would a normal two-step equation, so I'm going to subtract the 2. That's going to give us negative 12b, that's going to equal negative 1. And then we're going to divide both sides by negative 12. So when we divide by negative 12, of course, those are going to cancel. We get a b on this side, and then there's not really any simplification we can do with the numbers, but please don't leave this as a negative over a negative. A negative divided by a negative is a positive, so let's write that down as 1/12. Make that look just a little bit better. So b is equal to 1/12. Okay, down here on the bottom of this page, it says name the property illustrated. So this is where you've got to have all those properties that we talked about memorized. So that you can recall those. You can't use a cheat sheet on the test or anything like that. But let's take a look at what happened here. On this side, we have 7x and then plus 9x plus 8 in parentheses, the 9x plus 8 parentheses. And then on this one, the parentheses have switched so that they're around the 7x and the 9x, kind of so we could collect like terms and that sort of thing. This is the associative property of addition. So I'm going to write associative prop, and then I'm just going to write addition so everybody knows that we're talking about the associative property of addition. There is an associative property of multiplication also, so keep that in mind. So I'm going to go ahead and circle that, so there's our answer there. On this one, we've got 1/4 times 4y, and that equals 1y. So basically what's happened here is they've gone ahead and they've canceled those. So 1/4 times 4, that turns into a 1. That's the multiplicative inverse. So I'm just going to write inverse. Inverse. Okay, so those undo each other. All right, let's take a look at that next one here. We've got 5 times, in parentheses, 3x plus y, and then we've got 5 times, in parentheses, 3x plus 1y. So we've got a 1 here where there wasn't before. Of course, that doesn't change anything. So what that is that's the idea that we can multiply something by 1 and it doesn't change its identity. This is the multiplicative identity. So I'm just going to write ident here. Okay, so we've got that one. And we've got 3a plus 0 equals 3a. So similar to the idea right here, when we add 0, that doesn't change the number at all. It keeps its identity. So that's called the additive identity. So I'm going to write additive identity. So add ident, and we'll circle that, and that'll be our answer. Okay, let's take a look at this next page here. On this one, it says justify each step of the solution of the following equation. So I think we've got several of these. So we're going to need to be on our toes, and again, the best way to do this is to look at each line and see what changed from this line to the next line. So we're going to give a justification, we're going to give a reason for what happened right here, what changed from this line to this line right here. Again, have those properties memorized so you can keep those in mind. So here's what happened. This side stayed the same, and this side stayed the same. The only thing that happened is on both sides we multiplied by 3 times 8, or in other words, we multiplied by 24. Well, what we're doing here is we're trying to clear the fractions, and we're taking advantage of the multiplication property of equality. Okay, so I'm going to write down mult prop of equality. Okay, and we'll just put an equal sign there. Next one, let's take a look at what happened. On this side, let's see, we've still got the 3x minus 4, we've got the 3. The 8's disappeared, and on this side, the 3's disappeared. So that's going to be the multiplicative inverse, because multiplying by 8 and dividing by 8 are inverses. So we're going to write down mult inverse. Okay, so the multiplicative inverse there. Next one here, let's see what happened. This side didn't change at all, but this side did, and what they did is they just distributed. So that's the distributive property. So I'll just write distributive. We'll abbreviate it that way. And here we've got, gosh, nothing changed over here, and the 2 times 8 changed into 16. So you could just say arithmetic, or you could just say simplify, or you could say multiply, or whatever you want to do. I'm just going to write that we simplified. Okay, or I'll just write simplify. Okay. Next one. What we're doing on this step right here is we are adding 12 to both sides. So this is the additive property of equality. So add prop equality. Next one, what we did is we've still got the 9x, and the negative 12 plus 12 turned into a 0. So that's the whole idea of additive inverses. So I'm going to write additive inverse. Additive inverse. We'll abbreviate that just a little bit. Nothing changed on this side. Over here, we've got 9x plus 0 equals 9x. The other side didn't change at all. So that's just the additive identity. So we're going to write additive identity. And then you'll notice that what changed on this next line is the 9x stayed the same, but instead of writing 16 plus 12, they wrote a 28. So that's just going to be addition, or that's going to be simplifying, or you could write arithmetic, any one of those. Simplify. And over here, let's see what happened. The only thing that changed, we're going to divide both sides. So this is the division property of equality. And then notice again the 9's canceled. So when those things cancel, you know you're working with an inverse. They cancel to be a 1 through multiplication and division. So this is going to be the multiplicative inverse. Multiplicative inverse here. And let's see, are we on the last step? We are. The only thing that changed is instead of writing 1x, they wrote just an x. So that's the idea that we can multiply by 1. The number keeps its identity. So this is the multiplicative identity. Multiplicative identity. Okay. Again, got to have those properties memorized. Lots of different ways to kind of vary the way that you write those, but you've got to make sure that you have those down. Let's take a look at what changed from this line to this line right here. The 8 to the x stayed the same, but now they've written 4,096 as 8 to the 4th. You could double check this on the calculator. It is correct. So what they did here is they did substitution. So substitution. Remember, if you try and abbreviate substitution and subtraction, you got to be a little bit careful with that. So I'm just going to go ahead and write out the words substitution. And then remember, if the bases are the same, the exponents are the same. So basically, we just drop those bases. We get 4 equals x. That's the exponential property of equality. And then the last one, the only thing that changed is we flipped sides here. This is a little used property, but we're going to go ahead and write it down. This is the symmetric property, 2 m's in symmetric. So let's go ahead and write that down, symmetric property. All right, let's check this next page here. Okay, on this one, they don't give us the solving steps. We've got to solve it, and we've got to justify each step. So let's take a look at what we're going to do here. I mean, if we were going to solve this, just stop and think about what we'd do. We would probably distribute through here. So I'm going to go ahead and distribute through. We're going to get 10 equals 2x minus 10, and we're just going to write distribute. On the next one, we'd go ahead and solve this by adding 10. So I'm just going to write plus 10 here, and I'm going to write plus 10 here. So we're going to write the addition property of equality. This is going to give us 20 on this side, and on this side we're going to have 2x, and we're going to kind of belabor the point here. These are inverses. We do want to show that we know all those properties. We want to show people that, you know, those just didn't disappear. It turned into a 0. So this is the additive inverse because they cancel. Remember, when something cancels, it's always going to have something to do with an inverse. So this is going to be the additive inverse. Additive inverse. All right. And the next thing we're going to do is, this is silly to kind of keep this around, so we're just going to write 20 equals 2x. That's the additive identity. Okay, so additive identity. And we'll keep solving this. We're going to go ahead and divide by 2. I'm writing this kind of big so it kind of takes up that line also. So we're using the division property of equality. We'll do a little bit of simplification here. So this is going to be a 10, and this is going to be a 1x. And again, we're just kind of belaboring the point here. So we've done some simplifying on this side. Simplify. And on this side, this is the idea that those undo each other. So that's going to be a multiplicative inverse. Multiplicative inverse there. And then really the only thing left to do is to write this down as 10 equals x, because that's the multiplicative identity. So we'll write multiplicative identity. Okay. Now, if you wanted, you could flip this around and you could write it down as x equals 10. It's not absolutely necessary, but if you wanted to cite the symmetric property, you could go ahead and do that. All right, let's slide down here and take a look at this next one. Might take a little bit of work here. Holy cow, we're going to be grabbing our calculator on this one. 3 to the x equals, okay, let's see here. We know a couple powers of 3, so if I were to do 3 to the 4th, that's going to be 81, so we're going to have to go a lot bigger than that. So let's do 3 to the 9th. Let's see how big. Oh, hey, what do you know? We got it right off. If we had not guessed what that was right away, you could just do 3 to the 5th, 3 to the 6th, 3 to the 7th, and so forth. So this is going to be 3 to the 9th. Had we guessed something that was too big, we'd just back it off just a little bit. Like, had I guessed 3 to the 11th and that was too large, then we would have gone down to 3 to the 10th and 3 to the 9th and so forth. Just kind of trial and error there. So we're going to cite substitution there. Substitution. And on this one, we're just going to say x is equal to 9 on here, because if the bases are the same, then the exponents have to be the same. So this is the exponent, exponent property of equality. And then there's really nothing else. So again, you don't have to use every single line on these problems. All right, let's take a look at the last page, see what we've got going here. All right, on this one it says solve each formula for the specified variable. So this is where we're looking at the equation or the formula, and the only variable that we truly treat like a variable is the one that we're solving for. So in this particular case, we're going to be solving for b. That means we think of everything else as a plain old number. So if we're going to solve this for b, this is the variable term because it's got the b in it, which means we want to get rid of the a. So we're going to subtract the a, and luckily we don't have to justify all these steps. So let's take a look here. We get negative 3b. And then on this one, you could write the a first, you could write the c first. It doesn't really matter. I'm going to go ahead and write c minus a. That way we've got a leading sign that's positive. And then we're going to divide this side by 3, divide that side by 3. So here's what we get. We get b equals c minus a over negative 3. Now, if you were to circle this answer, there's nothing wrong with writing the answer this way. But there is something that we don't like about it. We generally don't like negatives in the denominator. So one thing that we can do is we can take that negative and we can bring it out front, and then we can slide it on the top. Remember, there are 3 ways to write a negative fraction. We can write it out front, on the top, or on the bottom. The bottom is the least favorite place. So here's what we're going to do. We're going to take that and we're going to move it on the top. So this is going to be c minus a. And if you don't put the parentheses on here, what you'd get is minus c minus a over 3, and that is not going to be correct. That negative has to distribute through to everything in the numerator. So here's what we'd get. We'd get negative c, and then we'd have plus a over 3. Now, the best way to actually write this is to write this as an a minus a c over 3. There are a couple good things about this. First of all, it's in alphabetical order in the numerator, and we've got a leading sign that's positive. So we kind of like that. Now, had we written this as negative a plus c over here and then moved it up there, that might have saved us a little bit of work. But either one of these is going to be okay, totally fine. Good answer right there. Let's take a look at this next one. On number 18, it says solve for t. So the only variable in this problem is this one right here. Now here's the big issue. When we solve for a variable, we need to make sure that it's in the numerator. Right now, this is in the denominator. So here's the first thing we're going to do. We're going to multiply both sides by something that's going to get rid of that denominator. So it's usually just going to be easier if we don't have a denominator in there. So what we're going to do is we're going to multiply both sides by 2t. So if we multiply by 2t on this side, we end up with 20t, and if we multiply by 2t on this side, the 2t's cancel, so we end up with just a plain old s. So the only thing that we need to do to get the t all by itself is just get rid of that multiplying by 20, so we're going to divide by 20. We normally write the variable that we've solved for on the left-hand side, so I'm going to go ahead and use that symmetric property, flip this around, and then write the answer that way. So totally okay there. We're in good shape. We're almost done with this. We want to solve this equation for p. Notice, unlike the last one, the variable that we're solving for is in the numerator, so we're in good shape there. So I'm also going to clear the fractions on this one. So I'm going to multiply both sides here by r. So if I multiply by r, and let me go ahead and make this look a little bit better. We'll multiply both sides by that. So those are going to cancel. I've got 3pq equals 12r. And then we want to get rid of the 3 and the q. Now you can do these separately or you can do them at the same time. This is one big multiplication problem. So I want to get rid of multiplying by 3 and multiplying by q. So we're going to divide by 3q. So we'll go ahead and cancel here. So here's what we end up with. We end up with p on one side all by itself, which is what we want. The r and the q can't cancel, but we can cancel the 12 and the 3. 3 goes in here once, 3 goes in here 4 times. So the best way to write this, the simplified way to write this, is p equals 4r over q. All right, let's take a look at the last one, and we will be all done. Okay, we want to solve this for y. Y is in the numerator, so we're in good shape there. So again, I'll multiply both sides by something that will cancel off the denominators. So I end up with 2a over here. Those 2's cancel on this side. So we have x plus y, and all we want to do is we just want to get y by itself. So we're going to get rid of that x by subtracting x. Those are going to cancel, so I'm going to write down y equals. We're going to have 2a, and you might remember us talking about this. The nice thing about working with formulas and solving for a specified variable is a lot of times there's very little simplification that can take place. In fact, on most of these problems, there really wasn't any. The only simplification we could really do on this one was divide the 12 by the 3, and on this one, move the negative up in the numerator. So if you can do those problems, you should be in good shape for the quiz. Good luck.